Hello, this lesson is it's about your homework. Okay, so I'm going to take some examples of your homework for week 2, and if we have time, we will make we will also talk about some homework questions on week 1 for your reference. And of course, you can always take them, ask, get these answers from other textbooks. Pretty much every textbook has coverage of these materials, but I thought it would be helpful if I have, I put them here for your reference. Homework for week 2. Okay, let's look at the first one. The first one is about operation of, on functions, including adding, subtracting, multiplying, dividing. Okay, the question at hand are, we have f of x, which is a, x squared, and g of x is 3x minus 2. Okay, I will review the related material about these functions and also, let you know how much work you need to show. Okay, first of all, review the concept. We know that both functions are, each function is a rule. So for this function, the rules are, right? So if I put in a table, so that make it easier to observe, right? As for the first function, it's a rule. And the second function, of course, is a rule. So what do we see them? It has input, right? The input follow the rule, right? And the rule is, of course, we take the input and produces an output. That output is x squared, right? The output is x squared. We know the domain and we know the range, right? Domain, range in one sentence, we all know that, right? G of x is another rule, right? X the input and the function rule is called g. It has a specific rule. So that's the output. When you show your work on the homework, you don't really have to show these things I have here. This just review the concept. And take one of the questions, for example. I start with a simple one, right? Number 7. Okay, number 7. Number 7 says 3 times f. Okay, that's a function on x, right? The reason I take this question first, because I think I didn't cover this kind of example in the lecture. I only talk about it, but I didn't mention it. So this equals to 3 times f of x. Okay, 3 times f of x. How does it work, right? Rule-wise, right? So domain range for G is all real numbers. Domain for x squared, we know the all real numbers, and the range is non-negative numbers, right? So we can write it down. Just be aware of them, right? Domain is all real numbers. Then I will come back. Okay, I will come back. Domains all real numbers, and the domain and the range. The range is x squared at least 0. At least 0. So we got domain, range all covered. On the other one, right? Domain is all real numbers, and range is also real numbers. Range is all real numbers as well, right? Because that's a straight line. Range is all real numbers as well. Okay. Now, so for number 7, when we have a constant multiply a function, and then the rule just has become, this is how the rule works. X will be the input for f, right? It comes out as f of x, right? And this output, excuse me, is going to multiply by f of x. So three times. So that's how the flow works. As far as for showing your work in this case, right? All you have to do is just to do this. Okay, 3f of x equals 3 times f of x equals to 3 times f of x is x squared. So it's 3 times x squared. That's it. Okay, you don't have to write all of these. As far as the amount of work you need to show, just this much for number 7. Okay, number 1. Okay, number 1 is adding, addition f plus g of x is equals to f of x plus g of x. Okay, and we understand, right, as a rule, f plus g, I'm going to I put another column just to review the concept, right? So just review the concept. So we add a column. So f plus g, the flow is we have input, and this input is going to give it to f plus g. Okay, and the output is going to be f of x plus g of x, right? It's going to be f of x plus g of x. That's it. Okay, so these are just for our understanding as far as how much work you need to show. And f of x is x squared plus g of x is 3x minus 2. Then you're done. Okay, subtracting, I'm going to pass. Multiplication, multiplying. F multiplies G. Okay, this may be confused with composition, so be very careful about the notation. But I think most of the time, I haven't seen many confusions, but so this will be f of x multiply g of x. Okay, so this is going to be x squared multiply 3x minus 2 equals to, if you wish to expand it, it's 3x raised to the power 3 minus 2x squared. Done. Okay. Division, dividing. Okay. In all of these situations, domain, there's no change in domain. Okay. For division, however, we have to be aware of the domain, because we need to make sure the domain is not going to cause zero denominator, right? So this is going to be f of x. Oh, wait. Okay, f of x over g of x. And in our case is x squared over 3x minus 2. Since g of x cannot, denominator should not be 0, so we need to make sure that's going to be guaranteed. So we're going to make sure that denominator is not 0. Okay, this cannot be 0. As a consequence, if we adding 2 on both sides, which will have 3x equals to 2, divide both sides by 3, so x cannot be equals to 2/3. So that will be our domain. So that's going to be our domain. Okay, so you can say domain. That's a domain. Okay. That's number 4. Okay, let's do a couple composition. Okay, we've done F composite G. Okay, let's do F composite G then. Okay, 5 F composite G of X. Okay, so I'm going to bring the function, down below so I can see them, easily, and also manipulate them easily so you can see. Okay, we understand that this process actually is 2 layers. We go from inside out. Okay, so F of G of X, right? And that should equals to F of G of X is 3X minus 2. Okay, now F, the input for F is 3X minus 2. And F of X is X squared. So you can imagine if this X becomes 3X minus 2, and that's going to become what? 3X minus 2. You see that? Okay. So as a result, the last step is that. Okay, you can see that the initial X was merely a placeholder. Okay, so treat X as a placeholder. They just hold the place. Placeholder. Okay, let's do a G composite F. G composite F. G composite F. So that's going to be G of F of X. Okay. And the consequence is G of F of X. F of X is X squared. Okay. Now, G of X squared. So X is replaced by X squared. You see that placeholder is replaced by X squared. There, right? So the previous X is merely a placeholder. Okay, and I want to put a note here. You can see these two okay, G composite F and F composite G are usually not the same thing. So order matters. Order matters in the case in composition. In composition of functions. Okay, so the different order matters. Okay, and G composite G, we're just going to do G composite G. We're not going to do F composite F. I'll leave that for you. Okay, so last one, number 9. Right, G composite G of X equals to G of X. Okay, and G of X, of course, we do it from inside out. So G of X is, G of X is 3X minus 2, right? So 3X minus 2 will be the consequence of the output of G of X, right? G of X equals 3X minus 2. Now 3X minus 2 is in the place of that placeholder. And as a consequence, the output, right? 3X minus 2 will be in the place of X. So we're going to get 3 times 3X minus 2 minus 2. Okay, that's the result of composite function G composite G. So if we distribute 3, so we get 9x minus 6 minus 2, and in the end we get 9x minus 8. So that was that. So let's look at the second function, the second question. Okay, we have 6 questions there. Finding the inverse function for each of the 1-to-1 functions given below. Okay, find the inverse function for each of the 1-to-1 function given below. So we were told all these are 1-to-1 functions, right? The first one, let's do the first one as a warm-up exercise, right? So we got f of x equals to 5x plus 6. It's linear, it's 1-to-1. We're told it's 1-to-1. If you graphed it, you're going to see it's a straight line. It passes horizontal line test. Therefore, it has a unique inverse, right? So to find the inverse, we start with y equals to 5x plus 6. And step 1, we have that 2 steps, right? 2 steps. Swap x, y, right? Swap x, y. Domain and range are the same. Domain, range are both all real numbers. Domain is all real numbers. Okay. And the range is all real numbers. Is all real numbers. Negative infinity to positive infinity. Right? So when we swap it, the implication is also domain and range will be swapped. And this doesn't make any difference. So x will be equals to 5y plus 6. And step 2, we're going to solve for y. Solve for y. Solving for y from this equation, right? If that's true. And then we're going to just subtracting 6 on both sides. So we have x minus 6 equals to 5y. Okay. And then divide both sides by 5 or multiply by 1/5. So y is equals to 1/5 multiply x minus 6. You could write it, x minus 6 all over 5. That's fine too. Okay. Just for the moment, I'm just going to write it this way. Either one is okay. But this one sometimes is preferred for no particular reason. Okay. Maybe for the look. Okay. But anyway. So the inverse function, right? So the inverse function is 1/5 of x minus 6. Okay, domain range stay the same because after the swap, they're still the same. You can observe a couple of phenomena. For example, if you graph them, right? If you graph these 2 functions, right? If you graph these 2 functions in one picture, oops. Right? If we graph both functions in the same picture, we're going to see something interesting. Okay, they should satisfy all of those conditions we talk about. All right. So, for example, okay, I'm going to graph the inverse function, which is 1/5 times x minus 6. The inverse function, I'm going to make it red, right? I'm going to make the adjustment just in a minute, okay? And the second, the original function is 5x plus 6, right? 5x plus 6. 5x plus 6. So I'm going to plot the other function there. Ooh, we certainly need to make some adjustment, right? The scales are kind of off. This is 2, this is 10. So let's make some adjustment. You want to make the scale proper. Okay. So maybe -3 here. It's try and error. Okay. I don't necessarily get it right all at once. Okay, so I'm just going to try it. There. So the 2 is still kind of off, but if I shift it a little bit, right? If I shift it a little bit, so this 2 is about the same. It's still a little bit off. So this is about right? So we see that kind of symmetry, right? The green broken line that you remember I drew, right? The green broken line, is it still symmetrical about it? Yes, it is, right? So you can see that property still works. Another important properties I really want you guys to practice on is that we have the function, right? And we have the inverse. We know that the inverse is already found. I really want you guys to work on this piece, okay? Which is here, composition, because you will need to do this in the future when we're more into the, I would say, the trig function and inverse trig function, right? So this is the whole reason why we do it here. So now I want you to do F composite, F inverse of X, okay? Where this X is from the domain of F inverse. And I also wish you to do F inverse composite F of X. And of course, this X, the first X is from the domain of the inverse function. The domain of the inverse function is from, of course, it's -infinity to +infinity. Oops, sorry, +infinity. And this other X, right, this other X here, okay, this X is from the domain of F. They happen to be the same for this particular case, but I still want you to be aware of them. So you may like to, actually, I hope you guys will pause as you watch the recording up to this point, okay, to try to do it yourself, and then come back to watch the recording. Okay, so now I'm just going to go ahead and do it. Practice with this composition. Okay, so F inverse of X, and then move here, you have equal F of F inverse is 1/5 times X minus 6. So now this quantity is in the place of X for F, right? So you're gonna substitute it one more time in the rule of F, right? X is replaced by 1/5 of X multiply X minus 6. So this is going to be 5 times 1/5 of X minus 6 plus 6 plus 6. Okay, let's see what we get in the end. You know what we should get, right? But let's verify. This is 1. So the first part becomes X minus 6 and a plus 6. And we got it equals to X precisely. Okay, so this verified that these two functions are inverse to each other, almost, okay, because you need to check both. As we mentioned earlier, F composite G versus G composite F, they're not always the same, right? F composite G and G composite F, they're not always the same. So you really have to go, do your due diligence. So now with the second one, right? The second one, we have F inverse. Oops, F inverse of F of X. If these questions for some of you is easy, please be patient with yourself and be with me, because we will get into more complicated situations very soon. So knowing how to do these basic questions is very important. And F of X is 5X plus 6, right? So F of X. So we do it from inside out. F of X, 5X minus 6. And then, okay, and we're going to apply the rule of F inverse. F inverse is right here. And for F inverse, right, F inverse, X is the placeholder. Now the placeholder is replaced by 5X plus 6. So this X replaced by 5X plus 6. And that X will be replaced by 5X plus 6 as well. Okay, so our next step is going to be that guy. If that makes sense, okay? And now I can erase this one. All right, and equals to, we do inside the parentheses first. So 1/5 is outside, and inside is just 5 times X. In the end, it's X, okay? So if you ask me how much work you need to show, and this is the work I want you to be able to show it well, okay? Show it well, okay? So in both cases, okay, we have verified. What has been verified? And that is equals to X, and the other one is also equals to X. Okay, so we have verified all these properties that an inverse function and its inverse, right? Any one-to-one function and its inverse, they always have these properties, always, very consistent. The inverse function, the one-to-one function and its inverse that we learned before and after, they all have these properties. They all have these properties. Okay, that's what we're trying to demonstrate. That's what we're trying to demonstrate. Another question, I think I need to give you some more explanation, because I think number 2 should be explained. I suspect this might be a little bit hard for a lot of you. Okay, especially that question actually show up on the quiz. Okay, so X squared. Okay, X is less than 0. Okay, X is less than 0. X squared. First of all, we like to discuss the domain of this function. The domain is given, is forced upon this function. The domain is forced on this function. Why? To guarantee it's a one-to-one function, because without this restriction, the domain is all real numbers, which is not a one-to-one function. We understand that, right? So with this enforcement, with this forced domain, what is the range? Well, if X is negative, X squared is going to be positive. Okay, so for this function, the domain, of course, is X less than 0. And the range the range, any number time itself is positive. It's non-negative, but because x cannot be 0, therefore x squared is going to be positive. It's going to be positive. Okay. Now let's look at the graph. Let's look at the graph. The graph, right? This is the domain of real numbers, right? But what we have under the forced domain, it's only this piece. So that piece is not part of our picture. Okay, so we don't have anything here. Okay, so we're gonna make some adjustment for our pictures. There. Okay. So what we have is that over here. So this is the graph. And I'm going to make a little adjustment over here. And maybe just 10, right? So this will do. Okay, so this is the picture. And not including 0, not including 0. Therefore, I'm going to put a circle about that dot. Okay, a circle about that dot. So that point, meaning that this point 0, x equals 0 is not part of the picture. Okay, so maybe I can put a red dot there, a red dot, right, to make it more visible. Okay, so this is the function. Does its inverse satisfy that condition? Its inverse satisfy that condition? Well, this function is 1-to-1, obviously, right? Pass the horizontal line test. And so we're going to find the inverse. Okay, how do we find the inverse? The usual steps, right? So we're going to take that function with its domain and range. With its domain and range. Okay. And we will have y equals to x squared. Be very careful, okay? We'll have some very important details about to come up. Step 1, the usual step. Okay, step 1, the usual step, we swap xy. We're swapping xy. Okay. And so we get y becomes x, x becomes y. And the consequence of the swap, okay, the swap of xy, I mean the swap of the domain and range, right? So domain becomes range, range becomes domain. Okay, this is very important. This is very important. The domain will be for x, right? This domain is for the x. Now x becomes y, right? So y is going to be what? Y is going to be negative. Okay, x, right? X used to be y. Y was the range, which is greater than 0. Therefore, the new x is going to be positive. Okay, I want you guys to understand that. Okay, if you need to watch this again, okay, in the previous example, domain range swap makes no difference. But in this case, the swap on domain and range makes a big difference. Okay, before the swap, domain is about x. After the swap, x becomes y. So x was less than 0 become y less than 0. Before the swap, the range is about x squared. X squared is positive. After the swap, right? X becomes what? Becomes y, so X becomes positive, okay? So with that said and done, let's look at this, step 2. Step 2, we're gonna solve for y. We're gonna solve for y. When we're solving for y, okay, with all these attachment, right, we're solving for y. Naturally, we're gonna take square root on both sides. Okay, so we're gonna take square root on both sides. Can we take square root on the left? Well, x is positive, so we can take square root on the left. And we can take square root on the right-hand side as well. We take square root. And what comes next? What comes next? I want you to pause the video and see for yourself, right? The left-hand side is pretty straightforward. What will be on the right-hand side? The right-hand side, what should it be? Is it going to be y? If you answer is y, pause the video and think about it. Think of it again. If you've chosen y, it's a mistake. Okay, it should be absolute value of y. Okay. So now we still have the same assumption, right? It continue, not assumption domain range after it's been swapped. Now the question is, we're gonna have to solve for y. But knowing that y is negative, y itself is negative. Y itself is negative. The absolute value of a negative number, okay, the absolute value of a negative number is its opposite. So it equals to negative y. Remember our lectures last week about absolute value functions? Okay, I think we did that. Okay. I think it was in the example of definition of examples, right? In week 1. Okay. So the absolute value of a negative number, y is a negative number. The absolute value of a negative number is its opposite. This piece is very tricky. Very tricky. Tricky if you don't understand it. But once you understand it, it will become easier and easier. So as a result, y is equal to negative of square root of x. Okay, with domain range in the statement like that. Okay, right, so this is you can see the whole process, right? Now F inverse is found. F inverse is found. F inverse, F inverse is negative of square root of x. Domain, x is greater than 0, right? Domain, x is greater than 0, range, y is less than 0. This is pretty tricky, isn't it? All right. Okay. So now let's look at the graph, right? We did a graph for this function here, right? Now it's time to do the graph for negative root x. That's the inverse function. So we put the graph in place, make it red. And where did it go? Actually, it goes in this quadrant. Okay, so I need to, the software is, I'll have to do this. Okay, the software. There's negative x squared. Okay, I need to do that. Negative 10. This is the software. So let me just make a little adjustment right here. Okay. And hold on. Negative 3, positive 3. So this is more balanced. And the scale, right? At the scale. And it does not include 0. 0 is not in the domain for either one. And the 1 is about the same proportion. But what happened to this piece? I mean, this piece should not be there, but this software doesn't do it for me. Okay, so I just have to cross that out. I have to cross it out. Okay, I have to cross it out. This, just pretend this piece doesn't exist. Okay, this piece doesn't exist. And is it still symmetrical about with the y equals to x there? Yes, yes, it does. That green, broken line. See, they're still symmetrical. So this is the function, okay? X squared, let's mark it. This piece is x squared for x less than 0. And this piece is a negative root x for x is larger than 0. They are inverse function to each other. Surprising, right? Surprise, surprise. Yes. Okay, so that's the situation. Okay, that's the situation. I think I will do 2 more examples. I'll do 2 more examples, okay? I cannot physically remove that because the software just has to perform in a certain way, okay? But in your notes, just this piece and that next piece. All right. Without further ado, let's look at another example of finding the inverse. Okay. The other example, I wish to go to number 4. I think number 4 will do. Okay, number 4. 3 and 4 are similar in a way. Okay. Number 4 is that we have f of x equals to cubic root of x minus 1. Okay, this is a one-to-one function. This is a one-to-one function. Domain and range. Domain is all real numbers. And range is all real numbers. Is all real numbers. Domain range. Okay. So to find the inverse, well, we can graph it if you want to. Okay, we can graph it if you want to. Graph the function, so that's the function. It looks like it was a cubic root of x is shifted to the right by 1 unit, right? That's the function. That's the function. Okay, all real numbers. So I'm just gonna leave it at that. Okay, and we're gonna go straight to find the inverse. Okay, to find the inverse. So y is equals to that, right? So we're going to go back to do step 1. Swap. Swap x, y. Swap x with y right there. Okay. So we got x equals to cubic root of y minus 1. The consequence of the swap doesn't change much, okay? Because domain and range swap and domain range were the same. So it makes no difference, right? But they're swapped, they're still swapped, okay? And step 2, We're gonna solve for y. Solve for y. Okay. The consequence of solving for y, we're gonna power 3 on both sides. So we're gonna have x raised to the power 3 equals to y minus 1. As a result, we get y equals to x raised to the power 3 plus 1. Okay, and domain and range as such, right, after swap. So in the end, the inverse function is f inverse of x equals to x raised to the power 3 plus 1. So these are the two inverse functions. You can verify, right? You can certainly verify, right? F inverse, no, f of x equals to cubic root of that. Domain range are the same, right? So one thing you can verify is about the picture, right? If we draw the same picture, put two pictures in one frame, right? So this is the f, right? And f inverse is this guy. This guy, we'll make it red for that distinction, right? This is kind of hard to see. So let's make some adjustments. So they're separated. -5, 5. Okay, maybe we need okay, we may need more. We need a further separation. There we go. This is 2, this is 2. Maybe move a little bit further, right? They're symmetrical. They're symmetrical about that same line of y equals to x, that green broken line. Okay, that green line, symmetrical about that line. Inverse function, right? So we got that. And the other one that we wish to verify is the composition. The composition. We actually didn't do the composition for the previous one. Maybe you go ahead, do it, okay? If you have any issues, come back to tell me, to ask me. I'll be happy to help, okay? So inverse function, right? So f composite f inverse of x, right? And this x is from the domain of f inverse. You see, I'm repeating these important facts, which is very, very important. Very, very important. And the other one is f inverse composite f of x. Okay? And this x is from the domain of f. Okay, the domain of f, of course, happen to be the same as the domain of f inverse, but they're not always the same. Okay, so for each one, we're going to verify, right? So over here, we have the rule of these two functions right in front of us. So we have f of f inverse function, right, equals to f of f inverse is the same as x cubed plus 1, right? And then we got f of x raised to the power 3 plus 1. F function is right here, right? Now x cubed plus 1 is taking the place of x. So this is going to be cubic root. Okay, cubic root x cubed plus 1 minus 1. So in the end, we have cubic root of x cubed. And that's equals to x. That's equals to x. Okay, the next one. Different order. Okay, different order. F inverse. So the inside of f of x, inside is f of x, right? And that is equals to f inverse of f of x. F of x is cubic root of that, okay? And f of x is x to the raised power 3 plus 1, right? F inverse, right? F inverse is this guy. Okay, so I'm going to show you how it's been done. F inverse x, right? These two x's are consistent. When the inside the parentheses replaced by this guy, right? This x will be replaced by that as well. Okay, so that's what we got on the next step. So that's the concept of a placeholder. The concept of placeholder. Now, what do we get next? Right? The cubic root of x minus 1, there's a 3 power. So this is going to be x minus 1, and there's plus 1 outside, and in the end, equals to x. Equals to x. So both, right, in this case, once again, that we have demonstrated, right? We have demonstrated that this guy is equals to x, right? And this other guy's is also equals to x. But these two x's, even though they are called by the same name, this x, which is f inverse applied to it first, that x is from the domain of f inverse. This x, which function f applied first, so that x belong to the domain here. Even though they're not, they're by the same name, they actually mean different things. Okay, sometimes they are different. Okay, so in the future you will see that. Last one, last example before we close this this lesson. I wish to work for you number 5. Number 5. Okay, g of x equals to 1 over x plus 3. Domain. Denominator cannot be 0, so domain is x cannot be -3. What is the range? Okay, range, I'm just gonna give it to you. Okay, is that this guy cannot be 0. Cannot be 0, okay? Because it can be, I will explain to you another, maybe later. Okay, so for now, just take it. Okay, I will explain to you in time. Now, we're gonna go ahead to find the inverse. Well, if you like to see the picture, you can also see that. Okay, let me show you the picture. Okay, it's easy to get those pictures, right? It's pretty easy to get those pictures. But the picture tells us a lot of information, right? So I'm gonna just make some adjustment. So maybe this side is -7 and this side is 3. 5 is okay. So -5, +4. Right, so that picture, you can see the curve never crosses the x-axis. You see that? That means the function value will never be 0. So picture can tell it. Picture can tell it, right? The curve will never cross it. So this piece, they get as close as possible to x-axis, but it's always above it. On this piece, it's always approaching 0, but beneath 0. So one is in one direction is to positive infinity, and the other direction is negative infinity. And in this direction is approaching 0 from smaller than 0, approaching 0 from above 0, okay? So that's why it will never be 0. Okay, so without further ado, domain and range are set, right? So we start with y equals to 1 over x plus 3. Domain is such, right? Domain is such. For convenience, y is 1 over x plus 3. So are we going to write it as y is not equal to 0, right? Step one, swap. Swapping xy. Swapping, swap x with y. Okay. The consequence. So y becomes x, x becomes y. And how about the domain and range swap, right? Look at this. When x was in this situation, x cannot be -3. Now x becomes y. So y cannot be 3. Okay. How about the x? X cannot be 0. Well, y cannot be 0 before. Now y turn into x. Therefore, x cannot be 0. You see the swap. The consequence of swapping two variables implies the domain and range swapped at the same time. Okay, domain and range swapped. Very important to recognize this. Okay, and next, step 2. Step 2. Solve for y. Solve for y. Okay, when we're solving for y from here, what do? Because x is not 0, so we can flip both sides, right? We can imagine this is x over 1, right? So we flip both sides. Numerator turn into denominator, right? So 1 over x equals to y plus 3 over 1. Okay, and now we have 1 over x equals to y plus 3. So y is 1 over x minus 3. Okay, 1 over x minus 3. So the inverse function is found. And which domain and range is also indicated. It's also indicated. So let's see what they are. Domain and range. Okay. Domain and the range. Range. Okay, domain and range. Wait, is it minus 3? Y plus 3, minus 3. Okay. I guess. All right. So let's look at the picture. Let's look at the picture, right? So we're gonna bring that picture over here, and that was in, that was graphed earlier, right? That was in black. Now the inverse function is such as I'm gonna graph it as red, right? As red. Okay. And looks like they're pretty well scaled, right? 2, 2. Is this symmetrical about that green broken line? Is it? Well, it has to. It must be. Yep. Yep. Now, composition of the function and its inverse. Okay, composition. So we got F inverse and domain and range, right? We get F inverse, domain and range, right? And F, oh, you know what? I call it F, it should be G, okay? It should be G. Let's change it to F, okay? Because that's only change if we have to make any change. That will make the least changes, okay? So to make it simple, to keep it simple, okay? So now, once again, the composition, F composite, F inverse of X equals to, we're gonna check, right? But this X is from the domain of F inverse. We've been talking about this all the time, right? You see how consistent they are, okay? Mathematics has to be very consistent with itself. And the domain of F inverse is what? X is not equal to 0. Right? And the other one, F inverse of F of X. Right? And this X should belong where? The domain of F. And what's the domain of F? Domain of F is X cannot be -3. Right? So let's see, why cannot be? I might have made a mistake somewhere, did I? Why cannot be -3? Why cannot be -3? I think I made a mistake somewhere. Why cannot be? Oh yeah, I did make a mistake. So this is -3. So I was right. That was a -3. So bad. Sorry. So the Y cannot be -3. Okay. So X cannot be -3. Sorry about that. Okay. So let's go back to make sure you get the correction, right? Domain X cannot be -3. So Y cannot be -3. I dropped the negative sign. That was a mistake. So the range cannot be -3. Okay. I got it right here, but then I dropped a negative sign by mistake. And you can see the picture tell it, right? It doesn't, the horizontal doesn't get to -3, right? And over here, so X cannot be -3. So I made a mistake over there. Sorry about that. Okay, if you have any questions or if you're confused by me, please let me know. I apologize for that. All right, so now let's do the composition. Let's do the composition, okay? The composition F of F inverse X is equal to, you must do these exercise because if you don't get these simple cases, when we're doing composition of trig functions, it's going to be so much more difficult because in those other situations, it's a little bit more complicated than here, okay? So F inverse is 1 over X minus 3. And now it's F of 1 over X minus 3. So F of X is this guy. Okay, watch carefully. Okay, F of X is this guy. So F of X, this place is replaced by that guy. So this place is replaced by that guy. As a result, this place will be replaced by that guy too. All right. All right. So that next step is this complex fraction. This complex fraction. And you can see minus 3 plus 3, that makes 0. So you have 1 over X. 1 over X. Okay. So now to simplify, we use mathematical principle number 1. So we do X over X. Okay, X over X is 1. Anything times 1 stay the same. So X times 1 is X on the top. 1 over X times X, that equals to 1. So in the end, we have X. Okay. Now, so we have demonstrated that this is true, which is equals to X for what? For X from the domain. For X from the domain of F inverse. Okay, this X is from the domain of F inverse because F inverse is on X first. The rule of F inverse applies to X first. Second one. Okay, these details are absolutely crucial. Once you get them, you see that they're going to be, they're consistent throughout the semester. So now let's work on this one. So F inverse of F of X. F of X. There you go. Now, what is F of X? F of X is 1 over X plus 3. Okay, of course, this X is from the domain. Okay, so this X is from the domain. Okay. Domain of F, which is X is not equals to -3. See, consistency. All right. So with that done, equals to, I know this demands a lot of, patience from your part as well. Okay, but you really, really need to get this. F inverse, right? F inverse of 1 over X plus 3. So F inverse is right here. F inverse is right here. Okay, F inverse is right here. Okay, that's F inverse. F inverse of X is 1 over X minus 3. So now F inverse of 1 over X plus 3. 1 over X plus 3 is in the place of X. So it's going to be in the place of the other X. Okay, therefore the next step is going to be this guy. You see that? I recommend you put these on your scratch paper. Okay, put it on the side. Okay, so when you show your work, it's nice and clean. It's nice and clean. Okay, complex fraction. So we have one complex fraction here. So I'm going to multiply X plus 3 over X plus 3. You know that the numerator is the same as denominator. So this is 1. But why do I choose X plus 3? Because this denominator. So the top is x plus 3 times 1, and the bottom is 1. Okay, so in the end, we get x plus 3 minus 3 equals to x finally. So eventually we have demonstrated that this guy, okay, equals to x for x in a domain of F. So once again, you see these properties are being applied, Last but not least, determine even function, odd function. I'm going to do one example. Okay, so determine even function, odd functions, or neither. Okay, neither. Number 1, we have f of x. Okay, f of x equals to x raised to the power 3 plus x. So because the definition, so here I'm going to put some kind of guideline for you to think about. Okay, I put it think out aloud. Basically, you work on scratch paper. The definition of, according to the definition of even function, right? For even function, what's being required, right? It's f of x or f of a negative x is equals to f of x, right? For all of the real numbers, all of the x's in domain. This is for even, right? Even function, even odd. What's odd function? An odd function is f of inverse x equals to negative of f of x. You can certainly look at the picture, but I think sometimes you may find doing it algebraically it's also pretty easy. Okay, feel free to look at the picture if you wish. I'm going to show you the algebra way to do it. Okay, so this is even, this is odd. Whether it's even or odd, we have an f of x already. So we always need f of negative x and then compare with f of x. That's essentially what it is, okay? So you're gonna go about to do f inverse x, negative x. So x is replaced by negative x. So in the rule, by the rule of the function, right, this to the power 3 now is going to be what? Negative x plus negative x, right? By the rule of the function. And then what do we got? We got negative x to the power 3 is negative x times negative x 3 times, plus negative x is minus x, right? Now, equals, so this is going to be negative x raised to the power 3 minus x. And what is that? If we factored out the negative sign, we get x plus 3 plus x. What is x plus x to the power 3 plus x? That is a negative of f of x, because f of x is x to the power 3 plus x, right? So what have we found? That is, we have demonstrated that these two are equal. Oops. Oopsie, sorry. Okay, so these two are the same. What does that mean? It's our function. That is, right? Thus, you can say f of x is odd. Okay, f of x is odd. Let me do number 2, and then we finish the section. F of x equals to x squared plus x. Okay, for the same argument, right? We know f of x, and we know that to determine even or odd, we just have to compare f of x with f of a negative x. So f of a negative x here is going to equals to, right? It's going to equal to x replaced by negative x. So negative x now is going to be squared. Okay, and this x will be replaced by negative x as well. Now, negative x squared is the same as x squared. And over here is minus x. So now we compare. How do we compare? We compare these two. Apparently they're not the same, right? So we're going to say we can say f of x is not the same as f of negative x, right? Then we can say f of x is not even, right? The definition of even function. How about negative of f of x, right? F of a negative x. What is the negative of f of x? Negative of f of x is equals to, you put a negative sign in front of it. So that's a negative sign over, I'm sorry, in parentheses, x squared plus x. And that's equals to negative x squared minus x, right? So in this piece, f of a negative x and negative of f of x, when we compare these two, they're not the same either. So, and this function, right, f of negative x is not the same as the negative of f of x, right? So we can say f of x is not odd. So then the conclusion would be f of x is neither even nor odd. Finished. Okay. I think that should be a good coverage of the homework questions for you to use as a reference. Be sure you're going to do all of them all over by yourself. Okay. Really understand it, because we're laying the foundation for future harder contents. Okay. Harder contents. All right. So that's all for this lesson. I'll see you next time. Thank you for watching.